if you use your ruler, you can draw the tangent line from those, or the line that would connect those 2 points. So use your ruler, draw it as straight as possible. Now, you have to find the place, we're going to estimate the place, where the tangent line would have the same slope as that. Okay, so here's the steepness of that line. Where on my graph would the tangent line have about the same steepness? So clearly wouldn't be over here because all these would be negatives, right? So if I'm looking, here's my line, so looks to me like it's about right here. Remember, your tangent line just touches your graph at that point. Mine is slightly off because my board isn't calibrated very well, but it looks like it's about right there when my x is 3. That is approximately the place where this would be true. And we know it has to be somewhere in that interval. Okay, we were looking between 2 and 4, so it will turn out to be a number between 2 and 4. That's all the mean value theorem is telling us. So if we look at the next one, this time my interval is from -1 to 3. So when my x is -1, down there, when my x is 3, not here. So you want to use your ruler and draw the line between those. Then somewhere between -1 and 3, there should be a place on the graph where the tangent line, so the derivative, has the same slope as that. So can you estimate about where that happens? What do you guys think? Take a look. Try drawing it on your graph and telling me where it happens. Is it about when your x equals 1? You guys understanding what I'm trying to say here? Even though my graphs are really, really dark. Number 5, or not number 5, but let's look at this example. We are talking about the interval 1 to 4. So here's when x is 1 and when x equals 4. Okay, you could draw the line in between those. So I want the slope to be the same as the slope of that line. Does my curve ever have a place where the slope is the same as that? No. So why doesn't the mean value theorem work here? Corner. When there is a corner, remember the derivative doesn't exist at sharp corners. This breaks the second rule. It's not differentiable. So this one does not have any points that work because it doesn't meet the requirements. It's not differentiable there. If I look at this one, from 0, when x equals 0, to when x equals 2, will it work here? Why? Yes, this one we have a break in the graph. It's not continuous, so we don't have any points that work. So those requirements are very important. Let's do one. So I want to find a number that will make the mean value theorem work for my function f of x equals x cubed minus x on the interval 0 to 2. So first thing, you have to check the conditions. Mean value theorem only has 2 conditions. It has to be continuous on the closed interval, differentiable on the open interval. Is this? Why? It's a polynomial. So you can just tell me that. So it is continuous on the closed and differentiable on the open. Okay, so my 2 requirements are met. Then what the mean value theorem says is that somewhere the derivative equals the slope between the endpoints. So I'm going to have to find the slope between the endpoints. If my x is 0, if I put in a 0, what do you get out? 0. So I have the point 0, 0. If my x is 2, I get 8 minus 2, which is 4. So I have the point 2, 4. What? Yeah, I divided by 2 instead of subtracting. Just making sure you are awake on Tuesday morning. Okay. So now we have to find the slope between those. Slope is y2 minus y1 over x2 minus x1. So 6 divided by 2 is 3. So what I know is that somewhere my derivative equals 3. So now we do the derivative. It would be 3x squared minus 1. Then we set it equal to 3. And we're going to solve. Measure 1. Divide by 3. What would you do now? Square root. Plus and minus. Square root of 4 is 2 over the square root of 3. And of course we can't leave the radical on the bottom. Okay. I asked you to find the number c in the interval. Do I have 2 numbers? I have 2. Do I want both of them? I only asked for numbers between 0 and 2. So my c is only the one between 0 and 2, which in this case is just a positive. So sometimes they might both work, sometimes only one of them will work. You just have to pay attention to the interval. In terms of, we've talked a lot about like position problems, position, velocity, accelerations, those things. The mean value theorem tells us there is a place where the instantaneous rate of change is equal to the average rate of change. Okay, for example, if I drive 120 miles in a 2-hour period, okay, how many miles per hour is your average speed? 60. That would be your average. That means the only way that is true, does that mean you had to drive 60 the entire time? No. But at least once you had to hit a speed of 60. You can't have an average of 60 while always driving slower than that. And if you go higher than 60, you had to pass that 60 at some point to get there. So if you know your average, then at some point you're instantaneous. At one instant at least, you had to have that same speed. Go ahead and do this one. Just want to look at this application, see if we can figure it out. Suppose that f of 0 equals -3. and the derivative is less than or equal to 5. What is the largest f of 2 could be? So what we know is that we have one endpoint. We are looking for this other one. I'm looking for my y here, the largest it could be. The mean value theorem says somewhere the derivative equals the slope between these. So if I find my slope, y2 minus y1 for x2 minus x1, I get y plus 3 over 2. What do you know about that derivative? It's less than or equal to 5, so this has to be less than or equal to 5. So y is less than or equal to 7. So the largest y value we could have is 7. If you had anything bigger than that, then the slope would become bigger than 5, and it would not work. We have one more example, but I think I'm running out of time, so I'm going to stop here. Homework-wise, I have a handout for you. I'm going to go ahead and give this to you. It is not actually going to be due until Thursday. So tomorrow at the beginning of class, I will finish the last example in our notes, and you will have at least part of the class period to work on this.